Welcome guys. If it's first time seeing my channel or seeing my page, make sure you hit the thumb button and you follow my page. And if you're watching this session from YouTube, guys, make sure that you subscribe and you like the video. You know, that's how you can at least say thank you for what I'm saying, what I'm doing here, guys. You know, I'm not getting paid for what I'm doing, guys. I'm doing this to help many of you guys out there. So if you appreciate what I'm doing, guys, go ahead and subscribe to my channel and like the video, guys. It helps me to reach out to many people out there, man. Because if you don't like, man, Facebook or YouTube doesn't recommend my videos to other people. But when you like the video, you know, it recommends my videos to other audiences out there. That's what I need, guys, from you. You know, I need that, guys. I need you to, you know, to show the love, man, show support, man. You know, hit the thumb button below. So, guys, today I will discuss with you Newton's second law of motion. We've been doing Newton's first law, but today I will do Newton's second law. Newton's second law of motion. Newton's second law of motion. Newton's second law of motion. Yeah. We want to discuss Newton's second law of motion, guys. We know that Newton's first law, we know Newton's first law by now. I know because we discussed Newton's first law of motion on my previous videos. So today we will discuss Newton's second law of motion, guys. So what does it mean? What does Newton's second law of motion says to you guys? Because this formula is the equation for Newton's second law of motion, whereby we have a mass. F net is the mass. F net is the total force. Total forces acting on that body, you know. So this is the mass. This is the mass. The SI unit for mass is kg. This is F net is force. The SI unit for force is newtons, and this is acceleration. The SI unit for acceleration is meters per second. You know, if you want to explain or define these things, Newton's second law, Newton's first law, you need to understand what does it say to you. What is it saying? You know, you need to understand Newton's second law. You deeply understand it, truly understand what is it saying, guys. So I understand that when you push an object, that object will move to the direction of that force. It will accelerate to the direction of that force. So hence why you see that F net is comprised by these two components, which is mass and acceleration. So we cannot move something from the position, from its state of rest, without applying a force to it. And when you apply a force to that thing, it means that thing will move to the direction of that force. If I push a box to this side, it means that box will move to this side. It will go to the direction of that force. So Newton stated that when you exert a force, on an object, when you exert a force on an object, that object will move. I have to put comma here. Okay, I can say the object will move. Will move to the direction, or will accelerate. The object will accelerate. Let me include acceleration. The object will accelerate to the direction of the force. To the direction of the force applied to it. You see, when you exert a force on an object, the object will accelerate. The object will accelerate to the direction of the force you applied. Will accelerate to the direction of the force you applied. Guys, sorry for my mistakes, Yeah, it will accelerate to the force, to the direction of the force you applied. That's Newton's second law. You don't need to cram these things. You need to understand them. Don't cram, guys. So you can either apply a force to a moving object, or you can apply a force to an object which is on stationary. When you apply a force to a stationary object, that stationary object will move. So when you apply a force to the moving object, then when you apply the force, that object can come to rest or increase the speed. It depends on which direction are you applying the force. You might be applying the force in front of the object. So now your force you're applying, it will help to resist movement. It will act as a frictional force. But there is a frictional force, but you will be helping frictional force to put that object on rest. You understand? So we will discuss two scenarios. Stationary objects and moving objects. So you can either bring something to rest, or you can push an object and cause the object to move, or you can either bring the object to its rest, to rest. When it's moving, you can either stop it from moving by applying a force. You can do two things on an object. You can move it or bring it to rest. So we need to discuss about equilibrium objects. Before we can go to calculations and all those things, I need you guys to understand these things, because we will be we're gonna use these things throughout when we do calculations on Newton's second law. You need to know what happens to the object when the object is in equilibrium. What is equilibrium? When you say something is in equilibrium, what do you mean? Equilibrium. Equilibrium, it means the sum of the forces acting on that body, it's balanced. They are balanced, or they are equal, or it's zero. You understand? What am I saying? What is equilibrium? Okay. Equilibrium forces. When two or more forces acting on a stationary object, and that object remains stationary, remain on its stationary position, it means that object didn't move. So it means the force that you applied to that object, this is an object. When you apply the force, I apply 50 Newton force, and you apply 50 Newton force, and the object didn't go anywhere, because my forces and your forces are equal. So when the forces are equal, it means this object, it won't go anywhere. It's on equilibrium. Equilibrium means balance. The forces are in balance. There won't be a movement because the forces are equal. These things and this 50 and this 50 will cancel each other. So there won't be movement in this scenario. That's what equilibrium means. Equilibrium means the forces, the object is not going anywhere, or the object is only at stationary. The forces acting on that object they are equal. Because if they are not equal, it means now if you were applying 20 Newton force and I was applying 50 Newton force to this object, it means I will overpower you. So I will overpower you with 30 newtons. I will overpower you by by this force, 30 newton, because now my force is bigger than your force with this 30 newton. It means I will overcome your force, and the object will move to the direction of my force. Guys, I don't know if you understand what I'm saying. I don't know if you hear me, but I'm trying to explain Newton's second law in many ways, in different ways. So let me, so it means when an object equilibrium, let me say equilibrium. When an object is in equilibrium, it means there is no motion. It means there is no motion. It means if there is no motion, there is no acceleration. What determines that the object is in equilibrium? It can be at rest. When an object is at rest, it means it's in equilibrium, because now we know that the F net is equals to mass times acceleration, and acceleration is the change of velocity. So if there is no change of velocity, if this is 0, now the whole thing becomes 0. Hence why I'm saying in equilibrium, in equilibrium state, the object doesn't have acceleration. The object doesn't have acceleration. It means it's on rest, or it's moving with a constant velocity. So when when an object is in equilibrium, it means it's at rest, or it's moving with a uniform velocity or constant velocity. When an object is moving with a constant velocity or at rest, we know that this happens. F net is equals to 0. Here also F net is equals to 0. F net is the sum of the forces acting on an object. When the sum of the forces acting on an object cancel each other, then they give you 0. Then it means the object won't go anywhere. So now F net is equals to 0, and acceleration is also equals to 0. Acceleration is also equals to 0. So when an object is in equilibrium, we know that F net is equals to 0 and acceleration is equals to 0. So now, if an object is not in equilibrium, what happens? Not in equilibrium. Not in equilibrium. What happens to the object? If now the object is not in equilibrium, it means now the object has acceleration. It means there is a change of velocity, or it means now the sum of the forces acting on the object they are not equal. So now the object moved to the direction of the force which overpowered the other force. It will accelerate to the direction of the force, or to the direction of the bigger force. So when the object is in equilibrium, it means F net is not equals to 0, and also acceleration is not equals to 0. It means here we actually have acceleration. We have a change in velocity. Here it means now we have acceleration. Now we cannot have F net as 0. Now if we have acceleration, we can multiply our mass and our acceleration to get the F net, the F resultant. So we know F net is equals to mass times acceleration, and we know F net is also equals to the sum of the forces acting on an object. F net is also equal to the sum of the forces acting on an object. So guys, I will do example of what I was saying here, to show you with calculation what I'm saying here. So in this case, we have a box here with a mass of 30 kg. We have a box of a mass of 30 kg, and then Jabu is pushing. Jabu is pushing this box on a rough surface, on a rough plane, and then they say Jabu, he pushes this box with a steady velocity of 2 meters per second. Steady velocity. Steady means constant. So they say Jabu pushes this box of 30 kg with a velocity of 2 meters per second. He pushes the box with 2 meters per second, and now they say he applied a force. He applied a force of 200 Newton. He applied a force of 200 Newton, guys. So now they want us to find, number one, to find Fk, which is frictional force. They want us to calculate the frictional force experienced by this box when Jabu pushes this box with a steady velocity of 2 meters per second. Number one, they want us to find Fk, which is frictional force. Number two, they want us to find a normal force. Right now I know you know normal force. If you don't know normal force is the force that is acting at the right angle to the surface, like this. This is normal force. It's equal but opposite to our weight, or force caused by gravity, Fg. So he pushes this box to this side, which is our Fa. Guys, I'm already doing my first diagram force here, and this box will experience frictional force. So we have a total of 4 forces acting on this object. So is this object on equilibrium or what? How do you know if the object is in equilibrium? You know by this, because they say it's moving the box with this steady velocity. It means constant velocity. So we know that when you push an object with a constant velocity, we know that there is no acceleration. So F net is equals to 0. So if F net is equals to 0, then we know that okay, there is no acceleration. In this case, we don't have acceleration. Acceleration is 0 because it's moving with constant velocity. So if acceleration is 0, then we can't use this formula. Instead, let's take out the sum of the forces, the sum of the vertical forces and the horizontal forces, because we can see in this scenario that this box experiences 4 forces acting on it, and they are the horizontal forces, and we also have vertical forces. So which vertical forces are acting on this object? We have normal force. The sum of the vertical forces is equals to this normal and weight. Normal force plus weight. And we also have the sum of the forces acting, the sum of the horizontal forces acting on this object, and that is Fa plus Fk. So now you see is the sum. Yes, sum is it means you add two components together to get something else. So it means now in this case we know that these two forces are acting on the 2 opposite directions. So it has to be minus here, because now this is going on a different direction, or on the negative side of my direction. I take the direction that I'm pushing this box to as my positive side. Then the other direction, which is my opposite direction, I will take it as my negative side. As well as for my vertical forces, I will take this as positive, and I will take this as negative. So even here, I will say n minus w. So now, guys, how can we find Fk? So we're gonna use this formula in this scenario. So the sum of the forces acting on the horizontal is equals to F applied minus Fk. So we have F applied is 200. This is 0. This is 0, guys. You remember, F net is equals to the sum of the forces. So we don't have acceleration, so F net is 0. So here is 0. 0 is 0 because they are equal. 0. Fa is 200. in this case I can just say positive here, positive, because I will just look what I'm saying. It doesn't matter. I will show you what I'm trying to say. So you just solve for fk. Fk is equals to, you take this one to this side, it will be negative 200. Negative, it means it's going in an opposite direction to our applied force. This one is going to this side, and which is a positive side. This one which will go to this side, which is our opposite side to our F applied. So it's negative. Hence why you see it's negative. So you cannot leave your answer like this. Hence why after this you can say Fk to the left, to the left, to the left, guys. It just means it's going to the left in an opposite direction. So you can actually see that our Fk is equals to our F applied. That proves our theory that when you push an object with a steady or constant velocity, Fk is also equals to Fa. Our F applied is also equals to Fk, which is frictional force. They are equal. They are equal. So we found Fk, the one normal force. The one normal force. They want this. Before we can find normal force, we need to find weight. Weight is equals to mass times gravitational force. So our weight, mass is 30 times 9.8. It's 294 newtons. So we have weight. This is 0. Normal force. This is 0. Normal force. We want normal force. And then we have weight. It's 294. So we solve for, and we take this one to this side. Therefore, n is equals to positive 294. This one is positive. I said our normal force is positive because I take the upside. I will take my up as positive and my down as negative. I will take the right hand side as positive and the left hand side is negative. This is a Cartesian plane. You know, this is negative side, this is positive side. So now, guys, we see normal force is also equals to our weight. So this proves that this object is in equilibrium. This object is in equilibrium because we can see our Fk is equals to our Fa, and then our weight is equals to our normal, and then that's it. Normal force is equals to weight, and applied force is equals to frictional force. Easy peasy. Easy peasy. Easy peasy, guys. So I will do the last one. So this one now, This is a bucket. This is a bucket. In this case, we have a in this case, they say Joshua's job in the roof sealing business is to lift the warm bitumen. I don't know what is bitumen. What is this, guys? Bitumen. I think it's something that is used to, to seal the roof when it's leaking. Bitumen. I don't know what is that. Yeah, but Joshua's job is to lift the bitumen with this bucket. And then the mass of this bucket is 28 kg. The mass of this bucket is 28 kg. The mass of the bucket with bitumen on it is 28 kg. And then bitumen alone, it has a mass of bitumen alone, it has a mass of 23 kg. So bitumen alone, it has a mass of 23 kg, and in the bucket now, that the bucket Joshua is lifting, it has a mass of 28 kg with bitumen in it. So it means the bucket has a mass of 28 minus 23. 28 minus 23 kg, it gives us 5 kg. So the mass of a bucket is 5 kg. But the mass of a bucket with the bitumen on it is 28 kg. You understand? Yeah. So when lifting the bucket, Joshua raises the bucket with a steady velocity. He raises the bucket with a steady velocity. Again, keyword, steady velocity. Steady velocity. Steady means constant. Steady means constant velocity. It means this is in equilibrium. It means there is no acceleration when he raises this bucket. There is no acceleration. He raised the bucket with a steady velocity, slow, with a steady velocity. So when lowering the bucket, guys, when lowering the bucket, he lowers the bucket with an acceleration of, when lowering, he has the bucket experience the acceleration of 1 meters per second. 1 meters per second. When lowering, the bucket experiences 1 meters per second acceleration when lowering it, without bitumen in it. So it means now when lowering it, the mass is equals to 5 kg. When lifting it, the mass is equals to 28 kg with a steady velocity. So this is when lowering. This situation is when lowering the bucket. Is when he lowers the bucket. Now the bucket experiences 1 meters per second accelerations. It doesn't have bitumen inside it. It's empty. So the question, it says, what is the tension in the rope as the full bucket is raised? Tension. What is the tension? So guys, this is a rope. When you lift something with a rope, or when you pull something with a rope, the rope will experience what we call tension. It will experience tension in it. And when you pull something, tension is acting away from the object. So now tension is acting away from the object. It's acting away, it's going up. Tension is going up. and there is a weight or frictional force. There is a weight. No, yeah, gravitational force, not frictional force. There is a weight and there is a force caused by gravity. So now, in this case, it means this is my diagram force. This is my diagram force. This is my diagram force. Before you answer these things, before you answer any question based on Newton's second law, you need diagram force to determine the forces acting on the object. So this is tension, it's going up. This is the positive side. This is negative side. Where gravity is going is negative. This is negative, this is positive, and this is force caused by gravity. Our first question, they say, what is tension? They want tension. We need to find force caused by gravity. Force caused by gravity. Let's find force caused by gravity. Fg is equals to mass times gravity. Mass is 28 kg times 9.8. Is 274.4 Newton. 274.4 Newton. So we have this. It's 274.4 Newton. We have this. Now we want this. And we know this is in equilibrium because he raised this bucket with a steady velocity. And when he raises the bucket with a steady velocity, there is no acceleration. So F net is equals to 0. We know this. So this is 0 is equals to F net is equals to the sum of the forces acting, the sum of the vertical force acting on this object. So now this is 0. It's 0. This is the force acting on the tension plus force caused by gravity. Tension plus force caused by gravity. Then now, what is tension? What is this? We have this. And guys, this is negative side. It's going on an opposite, on a different direction to our tension. So it's an opposite direction to this one. So it's negative. I put negative here. So let's go ahead and substitute. Now T is equals to, I take this one to the positive side. I transpose this one to this side. So it will become positive. So T is equals to 274 Newton. You see guys, T is also equals to our force caused by gravity. Because this is in equilibrium, they raise it with a steady velocity. Now, this is equals to this. So the next question, they say, find the tension in the rope while the bucket is being lowered. Now they lowered the bucket. He's lowering the bucket now. When lowering the bucket, we know acceleration is equals to, we have acceleration. Now F net is no longer equals to 0. So now F net is no longer equals to 0. F net is equals to sum of the forces, sum of the vertical forces. So F net is now M times A. Forces when lowering, T minus Fg. T, because it's positive here. This one, T is positive. This one is negative. It's negative. Nothing changed. So now, when lowering the bucket, we know the bucket alone, it has a mass of 5 kg. The bucket has a mass of 5 kg with acceleration of 1 meters per second. Now, the problem comes here. Some of you will substitute this positive acceleration here. But now he's lowering the bucket. It means now the bucket is accelerating. On a negative, it means the bucket is accelerating through the direction of our FG, which is the negative side. So now this acceleration will become negative because it's going on an opposite direction to our positive side, to our positive direction, which is the up is positive, down is negative. So if it's going down, acceleration is negative. So in this case, mass is 5 times mass times acceleration. Mass times acceleration is equals to our tension. We want tension minus Fg is 5 times 9.8. 5 times 9.8. What is 5 times 9.8? 5 times 9.8. It's 49. T minus 49. This is minus 5 times negative 1 is negative 5. So now I take this one to this side because we want T. So when I take this one to this side, it's gonna be 49 minus 5. It gives us 44. It gives us 44 newtons. So tension is equal to 44 newtons when you lower the bucket. And when you raise the bucket, tension was 274.4 newtons. Guys, I am done. I hope you enjoyed the session so far. So go ahead and like the video and follow my page if you want to, get this kind of information for free, man. It's free, not paying anything, So go ahead and support me, man. Show the love, man. Share my videos, like my videos. I love you guys. Thanks for your time, guys. Bye-bye.